So in our previous videos, we covered the Spearman's product moment correlation coefficient, the PMCC, giving you that R value. There's another type of Spearman's test that's called the rank correlation coefficient, which is used for a slightly different set of circumstances, but it also helps us determine the strength of a relationship between two different variables. So let's go ahead and jump right in. So when I'm looking at this data set, I can see that maybe a straight line isn't the best way to go about it because it just doesn't capture as accurately. In fact, if I kind of connected all these dots, it would look something like that. So perhaps a straight line is not really as, it's really not the most effective way to represent this data. So when you want to use the Spearman's correlation coefficient when you have a non-linear relationship, which in this case is quite obvious to see. We also want to determine if it is a monotonic relationship, meaning it strictly goes up or it strictly goes down. So what is the difference between the product moment correlation coefficient and the rank correlation coefficient? So we're going to use Spearman's if the relationship is monotonic, but not maybe necessarily linear, but there is some kind of relationship that we are suspicious of or that we might be able to see. So Pearson's coefficient R is really the measure of the linear relationship, and then the Spearman's coefficient measures how closely the ranks of one data set are to the other. So both increase or decrease together, or the exact opposite of each other. As one data set increases and the other decreases, this is what we call monotonicity. Kind of a tongue twister there. It can therefore be used for non-linear data, and that's exactly why we want to use this. So we can see that none of these data here are linear. So if it's always increasing, well then we can just kind of see that the function is always increasing. It's always decreasing. Cool. It's always increasing. Cool. But whenever you have any kind of basically a squiggle or a wiggle, it's not monotonic and you're not going to be using this. Okay, so it needs to be always increasing, always decreasing, always increasing. It cannot wiggle or squiggle. All right. So if we move on, I can see that this is clearly increasing. So that's what we call a monotonically increasing function. I can see that this is clearly decreasing, a monotonically decreasing function. Here we got a squiggle and a wiggle. It's not monotonic, so I'm not going to be able to use it. So what we do in order to do the rank correlation coefficient is we quite literally rank the data according to its value. So let's actually go over an example to see what this explicitly looks like. So let's say I have two different data sets here, and I want to find the rank correlation coefficient for the following data sets. So let's say I have the time spent training, which I'm going to call X hours, and the time to run 2 kilometers, Y. So I got my independent up here, Y down here. And so what I'm going to do is I'm going to take this data right here, and I am going to rank it in this table here. So what is my greatest value? Well, the answer would be 45, clearly. What's my next greatest value? That would be 34, so that's going to be second in my data. Third up would be right here, my 29. And as you can see, I have two different sets. I have two values for 23. So what that means is that, let's say this was my fourth data point, and this is my fifth data point. Just like before, I am going to slice this in the middle, and that is what I'm going to put into my graphing calculator spreadsheet. So what's between 4 and 5? Well, 4.5 and 4.5. And then what is my last one? That is my number 6. So again, I have 6 data points, 1, 2, 3, 4, 5, and 6. So I should see 1 through 6 represented. And since I have equal values here and here, I'm just going to split the difference, call it 4.5. All right, so now I'm going to rank the Y component of this data set. So if I have, let's see, what's my greatest one? That is going to be 14. So this right here would be 1. My next greatest would be 12. So that'll go here, number 2. And then I'll have 3.5 and 3.5. And then 10 is going to be my next one. So that is going to be number 5. And this right here is going to be number 6. So what I'm going to do is I'm going to take this as like a new data set, and I'm going to put that into my list and spreadsheets on the TI N-Spire or whatever calculator you happen to be using. So now that I have my data set in my list and spreadsheet, I'm going to go ahead and go up to C1, make sure my cursor is not blinking, and I'm going to hit Menu, and I'm going to hit Statistics, Stat Calculations, and I am going to go ahead and run a linear regression test on this. My X list will be X, my Y list will be Y, and I'll hit OK, and I can see that my R value is negative 9.56 to 3 significant figures. So my R value is negative 0.956. What does that mean? Well, it means that I have a very strong and negative relationship between these two variables. So what that would do is that would suggest that the more hours that I put in to training, the shorter my time to run 2 kilometers would be, which kind of makes sense, right? The more time you practice something, especially like a run, the objective or the result would ideally be a decrease in the time that it takes. You get faster with more training. So that's why we have a negative relationship here. And that's exactly what our R sub S means. So if I wanted to write my RS value, I would write R sub S, meaning that the correlation coefficient for the Spearman's ranked is going to be negative 0.956, suggesting a strong negative relationship. So now what I'm going to do is I'm going to go ahead and rank this right here. So this is actually kind of interesting. So again, I'm going to order these. I'm going to have number 1 as my greatest value, and I'm going to have 2, 3, 4, 5, 6 being the subsequent, decreasing value. So it's in descending order. So what that means is that this right here would be number 1. This would be 2. This would be 3. This would be 4, and then this would be number 5. That's exactly what it's going to look like down here. So I'm going to write 5, 4, 3, 2, 1, because again, I'm just ranking them from greatest to least. So now if I go back up here to Y, in fact, let me move this up a little bit here. Let me move this up a little bit here. All right. So if I have 6, 7, 8, 8, and 16, clearly my greatest is 16. I'll go ahead and put a 1 in for there. My next is 8 and 8. So that'd be my second and my third value. So what's the difference? What's the middle between them? 2.5 and 2.5. Next would be 4. So that would give me the value of 4. Next would be, I'm sorry, cut that chain, I apologize. So 2.5, 2.5. 6 is going to be my next one, so that would give me a value of 4. And then 4 is my last one, giving me a value of 5, a rank order. So I have 5, 4, 3, 2, 1 for X, and then I have 4, 5, 2.5, 2.5, 1 for Y. So what I'm going to do is go ahead and put this data again into my listen spreadsheets and see what I get. So going back to my calculator, I'll have this right here, 5, 4, 3, 2, 1, 5, 4, 2.5, 2.5, 1. And just in like my last example, I'm going to hit statistics, stat calcs, linear regression to figure out my R value. I'm going to have X, I'm going to have Y, and I'll go ahead and see that my R value right there is positive 0.975. So my R value here is going to be 0.975. What does that mean? Well, again, what I'm looking at is the number of pets that I have and the time spent each week caring for them. So what it does is it suggests a very strong positive correlation between the number of pets you have and the amount of hours it takes to take care of them, which kind of makes sense. The more things that you have to take care of, the more time you're probably going to spend taking care of those animals or what have you. So again, this suggests a positive relationship, meaning that as the number of pets increases, or your X variable increases, your Y variable is going to increase, which in this case is the time spent caring for each of those animals. So again, that's how we rank our data and then put it back into the calculator and run a linear regression test and figure out the R value. So the actual calculator steps haven't changed. The only thing that we introduced is this ranking element to it. So I hope that made sense, and I'll see you all in the next video.